This is Miss Humbert here. Today we're going to be doing the Unit 8 Quiz 1 review. So we're going to be talking over what you need to know to kind of prepare yourself for that quiz. So let's go ahead and take a look at number 1. The biggest thing you want to do, remember, is break things down into pairs. So we're going to take 81 and we're going to split it up. So I want to look for things that I know multiply to 81. Well, that's going to be 9 and 9. Remember, our goal here is to break things down completely into factors. So then I have 3 and 3. So I have a pair of 3 here's and a pair of 3 here's. So I'm going to go ahead and write that underneath a radical. So since everything underneath my radical is in pairs, that means that there's going to be no more radicals. So I have one pair of 3's and then another pair of 3's, and you multiply those two together and you get 9, which makes sense, right? Because if you think about what we've talked about before, the square root of 81 is 9. Now, let's take a look at the square root of 162. Now, to be honest with you, I don't really know many things that go into 162. So what I do is I take 162 and I divide it by 2. So I'm going to go ahead and do that, and I get 81. So I know 2 and 81 multiply to 162. Well, 81 is a number that I'm a little bit more comfortable working with. So I'm going to break everything down in those 9's into primes. So now that I have that done, I'm going to write it all underneath that radical. So I'm going to have 2 times 3 times 3 times 3 times 3. So I have 2 pairs of 3's. So each of those pairs of 3's is going to come out on the outside, and then left underneath the radical is going to be that 2. So 3 times 3 is 9, and then I'm going to keep that 2 underneath the radical, so I'm left with the square root of 2. Let's go ahead now and let's take a look at number 3. So we want to break down 54. Well, I know that 6 and 9 go into 54, so I'm going to break that down to be 6 and 9. Well, 6 breaks down to 2 and 3, and 9 is going to break down to 3 and 3. Remember, if you're not sure what goes into a number, just start dividing things until you find something that works. And there's many different ways you can do this. So you're not tied down to one single way. You could go about this a different way. Maybe you divided it by 2. That's okay. So then I notice that I have 1 pair of 3's. So that's all that's going to come out of the radical. Then left underneath, I have 2 times 3. Well, 2 times 3 is going to give me 6. So that's my final answer for number 3. Now, let's take a look at 72. So 72 we can break down to be 8 and 9. Well, 8 here is going to break down to 4 and 2, and 4 I can break down to 2 and 2. So I have 8 all broken down into primes, and 9 I can break down to 3 and 3. So I'm going to go ahead and write that all underneath the radical. So I have 1, 2, 3 2's. Remember, you want to go all the way up to the upper leg there, and then 2 3's. So I have 1 pair of 3's and 1 pair of 2's. So then I have 2 times 3 when I take each of those pairs out, and then left underneath the radical is 2. So last but not least, 2 times 3 is 6, and then I have square root of 2. So let's go ahead and let's take a look at number 5. So for number 5, in order to simplify this, we're going to have to break down each of those radicals. So what I'm going to do is I'm going to simplify the square root of 24, and I'm also going to simplify the square root of 54. My goal is to get leftover radicals that cancel. So things that multiply to 24. Well, I'm going to go ahead and use 4 and 6. And then I'm going to break down each of those into 2 and 2, and 2 and 3. So I'm going to write that out underneath one radical. So I get 2 times 2 times 2 times 3. So left I have just 1 pair of 2's that I can pull onto the outside, and left underneath is 2 times 3, which is going to give me 6. So now I'm going to break down 54. Well, 54 has 6 and 9 that goes into it. 6 breaks down to 2 and 3, and 9 breaks down to 3 and 3. So I'm going to draw my radical, and I have 2 times 3 times 3 times 3. So in this radical, I can take out a pair of 3's. And left underneath the radical is that 2 times 3, which is 6. So now I need to go back and put this as a fraction over itself. So I have 2 over the square root of 3 that I found, divided by 3 over the square root of 6 that I found. So square root of 6 over square root of 6 is going to cancel out, and then we're left with 2/3. So that's my final answer. So this one actually doesn't even have a radical in it. So now let's go ahead and break down this next radical. So we need to break down 63, and we also need to break down 112. Well, let's start by breaking down 63. I know that 63 can be broken down to 9 and 7. Well, 7's already a prime number, so we're going to break 9 down to 3 and 3. Taking a look at 112. Well, 112 can be broken down to 2 and 56. Well, 56 then I can break down to 7 and 8. So 2 and 7 are primes, but I still have to continue breaking down this 8. So I break it down to 4 and 2, and then the 4 I can break down to 2 and 2. So let's write out our 63 radical. So we're going to have 3 times 3 times 7. So I'm going to be able to take out a pair of 3's on that one. And then I'm left with 7 underneath the radical. Let's take a look at breaking down 112. So for 112, I have 1, 2, 3, 4 2's. Remember, it really helps yourself if you write it underneath the radical in numerical order so you can help find those pairs. And don't forget that 7 way up there. You're going to have to take that one out as well. So we have 2 pairs of 2's that we can take out. So those are both going to go on the outside, and left underneath the radical is 7. So 2 times 2 is going to give me 4, and then you're left with the square root of 7. So now we need to go back up here and rewrite it as a fraction. So when we simplify the square root of 63, we ended up getting 3 square root of 7. When we simplified the square root of 112, we ended up getting 4 square root of 7. So we can cancel out those square roots of 7's, and we end up getting 3 over 4. And that's our final answer for number 6. Now let's take a look at number 7. So we have a bunch of letters here. So x to the 8th means that there are going to be 8 x's. So I'm going to go ahead and draw out 8 x's. And then I'm going to make my pairs 2, 2, 2, 2. So again, I noticed that everything underneath the radical ended up in a pair, which means there's going to be no radical left over. So then I'm going to have x times x times x times x, because I have 4 pairs of x's. Well, that's going to end up being x to the 4th when you multiply all of those together. Next, let's take a look at y to the 11th. So that means underneath that radical, I'm going to have 11 different y's. So let's go ahead and draw some pairs. 1, 2, 3, 4, 5 pairs. So I'm going to have y times itself 5 times on the outside of the radical, and then just once on the inside with that leftover y. So 1, 2, 3, 4, 5 y's. So y times itself 5 times is going to be y to the 5th, and then left under the radical is y. Okay? So now I want to take a look at number 9. So for number 9, now we have numbers and letters. That's okay, we got this. So I want to use green. Okay. So for that 27, we're going to break that down to 9 and 3. And then the 9 can be broken down to 3 and 3. So remember, when we're doing numbers, we pull from the end of every part of the tree. So then I have 1, 2, 3 3's and 1, 2, 3, 4 x's. So now I'm ready to find my pairs. I have one pair here, here, and here. So I have a 3 times an x under the outside, and then the only thing left without a pair is that 3 underneath. So x times x is going to give me x squared. So I'm going to have 3x squared square root of 3. So next, let's take a look at 75. So we're going to break down 75 into 25 and 3. Going to break 25 down to 5 and 5. So then we're going to go ahead and multiply each of those numbers out. So I have 3 times 5 times 5. Again, you could go a different way simplifying that 75. Maybe you used 5 instead. That's okay. And then I'm going to have 7 y's. So I'm going to write out all 7 of those y's underneath. So I have 5, a pair of 5's, and 3 pairs of y's. So I'm going to go ahead and write that on the outside. Remember, you have to have a pair or a partner in crime in order to escape out of the radical. So I have 5, and then 1, 2, 3 y's is going to give me y to the 3rd, and then left underneath the radical is 3 y. So my final answer is 5y to the third times the square root of 3y. Now let's take a look at 11 and 12 when there are multiple letters underneath. So first thing I want to do is break down 63. So I'm going to use 9 and 7 and then 3 and 3. So I broke down the numbers. So now what I'm going to do is write the numbers out along with all of the letters. So I have 1, 2, 3, 4 X's, and then I have 1, 2, 3, 4, 5, 6 Y's. So now I'm going to go ahead and circle my pairs. So I have a pair of 3's, a pair of 2's, a pair of X's, sorry, 2 pairs of X's, and then I have 1, 2, 3 pairs of Y's. So notice that there's no X's or no Y's left underneath the radical. The only thing that's going to be left underneath the radical is that 7. So I'm going to pull out a 3, I'm going to pull out 2 pairs of X's, and I'm going to pull out 3 pairs of Y's. The only thing that's left underneath the radical or the square root is that 7. So I have 3, x times x is x squared, y times y times y is y to the third, and then we're going to have the square root of 7. So that right there is your final answer for number 11. Next, let's take a look at number 12. So we need to break down 28. So I'm going to break that down to 4 and 7, and 4 can be broken down to 2 and 2. So now that I have all of my numbers written out, I'm going to write those underneath my radicals, and then I'm going to start counting my letters. So I have 1, 2, 3, 4, 5, 6 X's, if it'll let me, and 1, 2, 3 Y's. So I'm going to go ahead and circle my pairs. I have a pair of 2, I have a pair of X's, a pair of X's, and I missed an X apparently, another pair of X's, and a pair of Y's. So on the outside, I'm going to have a pair of 2's, 2 pairs of X's, so they're just going to become 1 when I take them out of the radicals. So we have 1 pair, 2 pair, and then I only have 1 pair of Y's that I can take out. Left underneath the radical, I have a 7, I have an X, and I have a Y. So x times x is x squared, and then we have a y, and then I have 7xy. So this right here is your final answer for number 12. All right, so let's take a look at these review problems, and this is actually going to be something that you need once we get to Unit 9. So when you divide things of like bases, you want to reduce the fraction that is in front, and you're going to subtract exponents of things with like bases, so x to x, y to y, and so forth. The biggest thing to remember is that the thing that has the larger amount of y's or x's, if it's on the top, it goes on the top. If it's on the bottom, it goes on the bottom. So first of all, 12 divided by 4. Well, we don't even need to reduce that fraction because 12 divided by 4 is simply 3. Then I have x to the 7th divided by x to the 3rd. Well, x to the 7th is on top, so that means my x's are going to be on top. So when I subtract those out, I end up getting x to the 4th. So that right there is my answer for number 13. So now taking a look at number 14, we do have to do some work to simplify that first. So I need to ask myself, what divides 16 and 12? Well, 4 divides both of those, so I'm going to divide them both by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. Next, I have x to the 5th divided by x to the 3rd. Well, my large amount of x's are on the top, so I'm going to write my answer on the top. And then 5 minus 3, because those are the exponents on my x's, is going to be 2. Then taking a look at y's, I have y to the 7th over y to the 10. Well, the bigger amount of y's is on the bottom, so I'm going to write that. Y to the 7th, or so 10, and when you get rid of 7, you're left with 3. So we have 4x squared divided by y to the 3rd power. So that concludes your review video. Let me know when you're ready for the quiz. Thank you for listening.